Okay, so initially I'm talking without presentation because this is a bit of a story of two presentations. Both of them pictures, and something of a before and after. To give you some background, 4 years ago I started a company, initially just consulting, and initially it was only me. I was the only, it was my consulting company. After about a year, I was looking to sort of grow the company, particularly because I developed a number of open source solutions, and I wanted to extend the company and do more things. So really, when I was thinking about this, I was thinking, well, a lot of people ask me about, well, they're working for a big company now, but maybe one day they'd like to have their own company. What would that be like, and what are some of the challenges you come across? And that's really the topic of this talk, is that some of the challenges that have occurred over the last 4 years in terms of growing the company and how it's evolved, and in particular how my role has changed. So that's perhaps the warning, is that if you have a successful company, your role within the company will probably change, and you won't be doing as much development as you used to do, which is what you enjoyed, and perhaps why you started doing this in the first place. So in any case, until about a little over a year ago, we were very much a consulting company, and I used to do a lot of development, and most of the time for me was spent doing software development. However, as time went on, I started employing staff, so then I became a manager, which is something I'd seriously avoided for many years. I'd managed to go for about 20 years into my career without doing very much management at all, and very happy for it. However, running my own company, I thought, well, actually, it's a bit different. You're setting the priorities, and you feel like, well, you're doing this for your own purpose, so you can get to develop bigger solutions than you could do individually, but maybe you don't spend so much time with hands-on coding yourself. And that was about a year ago. Now we've switched to away from consulting, more towards selling products. And the reason we've switched towards products is that products scale much better. So with consulting, if you sell a day's worth of time, you can't sell that again. You need to do another day's work to sell another day's worth of time. And even though the daily rates have gone up as we've developed our expertise and we've developed our methodologies, it still doesn't scale particularly well. What does scale much better is products, because you can take a product and more or less, to some degree, sell it again and again and again. And because you can do that, you can actually make more money with higher margins, but also means you can spend more time on the product, improving and enhancing it, and you can really develop a solution you can be proud of. So we've shifted more to developing licensed products. Still doing software development for myself last year. This year, however, it's been a bit of a change, and you'll see this hopefully in two presentations that I've done. One I did at the very start of the year, which was to join a program called Accenture's Innovation Lab in London. It's a lab they do every year in a number of cities around the world, and part of the point of this lab is to help startups go from an idea to actually developing that idea and potentially raising VC money. In our case, we had more than an idea, we had a solution that had been proven, but from a commercializing point of view, we'd never really done that. We'd never really thought about a business plan or a roadmap or any of those sorts of things. I was only really worried about the solution, developing something that worked. So I'm going to show you the first presentation, which is what we used to get into the lab. But you'll see that it's very technical, and that was certainly the feedback at the time. I just need one prop. Which is in my bag. Okay. So we'll start with the first talk. So this is the presentation I started with, which is an introduction to who we are as a company. I'm the CEO of Chronicle Software, And we're about delivering low latency infrastructure solutions, in particular Java components for building business components in-house. Our main competitors are actually companies that in the past have built an entirely custom solution. Maybe you don't have to customize everything. Maybe you can spend more time focusing on the business if we can provide the infrastructure to allow you to build those systems. And in particular, our focus has been on trading systems, mostly for banks, investment banks, hedge funds, and trading firms. So our emphasis is on speed, usually transactional work, which doesn't necessarily scale horizontally. You need each box to do a lot more work, which means lower latencies to achieve higher throughput rather than more boxes to achieve higher throughput. So that's been our background. So about 6 years ago, I worked on a solution for a company in London that was building a low latency trading engine. And in fact, I went through quite a lot of jobs in London before I started my company. I had 10 jobs in 10 years, most of them permanent. The longest job I had was a contracting role, which was 2.5 years for UBS. I enjoyed working there, but yeah, most of my permanent roles were quite short, perhaps embarrassingly so. But the challenge for me was that I liked good technical challenges. And once the technical challenges had largely been solved, I got bored and moved on. So in 3 of those jobs, I'd moved on within 6 months. In this particular company, I joined a company that had an interesting technical challenge, or at least I made it interesting. They wanted a matching engine that could do 1,000 orders a second, but I said that wasn't very interesting, but I'd do it if you made it 10,000 a second. That sounded a bit more interesting. About a month into the project, we were supposed to take 6 months, but I was sort of feeling like we're about halfway there. So about a month into the project, I was getting some rough estimates. I thought we should be able to do 30,000. After 2 months, we'd finished most of the core system. There was still a lot of things to sort out, but built the core system. It was doing about 100,000 a second. But I thought we could do a lot better than that, because the biggest challenge we had was actually not what the business logic was, the infrastructure. It was sending messages over loopback was our biggest bottleneck. In the system. The actual time spent in Java was actually really small. So I came up with this idea of using shared memory in Java. And to my knowledge, no one had really attempted to use raw shared memory between JVMs. That's not using any system calls, just shared memory mapped to 2 JVMs at once. And after running something very custom for them, after about a month, we got it to 1 million orders a second, which is a lot to do in one box. And in fact, for 2008, which was a fairly busy year, it could process all the equity orders in the world in 15 minutes on one machine. So we sort of thought, I was starting to think, there's no point making this any faster. And I was also starting to get bored because the next 2 months I didn't have anything to do. So I left while I was still on probation for that job. But eventually that company went on to be very successful. So I was quite pleased with that. A couple of roles later, and starting my own company, I thought, well, how can I make these data structures a lot more generic so they can be used? Can I develop something that can be used across multiple applications, not specific to one? And that's how I started the Chronicle brand. Originally just one product, then a whole suite of products. So the modern challenge is actually around using hardware. Hardware is so cheap. I know banks have an interesting way of making the cost of disk space in many organizations is proportional to the size of the organization, but for smaller organizations or more agile ones, then they can work more at retail price. And 2 terabytes of SSD you can now buy. This is the Enterprise Edition for around £1,000. And if you think that this is huge, this is actually how big it is. It's this thing. It's only that thick and it's tiny, right? Fits into a laptop. Of course, you can put several of these in one box without too much trouble. If you spend £100, you can put 4 of these on a PCI card. So you can get a lot of space into a server for not much money. The challenge is, well, how do you use this from Java effectively? So what we've done is a lot of our solutions, like I was talking about this shared memory, is actually using a thing called memory map files. And a lot of databases use memory map files. It's a very common practice. But what's unusual about our solution compared to some of the others is that we allow sharing of those memory map files between multiple processes, different processes at once. Whereas most databases require you to connect to that database, and then that database then accesses that shared memory, not allowing you to embed it into multiple JVMs simultaneously. And as I mentioned, big hit is TCP. TCP over loopback isn't as cheap as you might imagine. To the point where if you have a high-end, low-latency network card, you can actually pass data from one JVM to another in another machine and back again in half the time you can send data over loopback. That's how bad loopback is these days. So we've got a client that they can round trip between JVMs on different machines in single-digit microseconds. Whereas loopback is usually about 10 plus, and on a Mac it's about 30, which is quite high for the same hardware. So if you can avoid loopback, then you can get enormous latency saving. The significance here is that most C and C++ solutions really have to have loopback because you need a degree of isolation between your data set and your program. So if your program crashes or corrupts the memory, because it's quite easy to do in C++, then you want to protect your data. And to provide that isolation, you have to put it in another process, which then means you're going over loopback, you're paying that penalty. Whereas in Java, you have a built-in degree of protection. If a thread crashes, it's most likely just going to throw an exception. It's not necessarily going to corrupt all your memory as a result. Actually, in Java, it becomes more of an option to just embed that data straight into the process. And as a result, get much lower latencies than you could achieve with the standard C++ solutions, which is an interesting outcome of this. We had a user, they use Chronicle Map, which is our key value store, and just by switching in that data store and this is compared to using concurrent hash map, by the way, which is already very efficient and very fast, they managed to halve their AWS bill. Just by making all the data storage more efficient. Chronicle Map also gives you the bonus of persistence. So one of the key messages we have is that if you do persistence right and efficiently, you can actually make the system faster by persisting everything than maybe the alternative solutions. So we have a client in the US. They actually get peaks of 30 million events a second. For options feed for equities. And they persist all of that through our software. So there's a fairly aggressive persistence rate. They have about 200 terabytes of data going back 3 years, and they can replay any of it from any point in that time. So that's a very long buffer, shall we say. So we've got an equities trading system in the UK, and one of the benefits they have is they can replay any day, so they can take the event source data file for a particular day, replay it to any point, check why did that event process the way it did, but more importantly, play it again and have confidence they really have fixed the bug. So we have this Chronicle queue. It's multiple writers from multiple JVMs, and it can be picked up by multiple JVMs in turn. We also do replication across the network. We also support low latency, and not only low latency, but high throughput low latency with encryption. So at 1 million messages per second encrypted, we can get around 10 microseconds 99% of the time. And at about 400,000 messages down here, it's about 2 microseconds 99% of the time. The Chronicle map is our key value store. It has similar sorts of metrics, but of course it's overwriting values. You only have a latest value in map. Q keeps a complete history. We have a fix engine, and the fix engine is actually our biggest source of revenue. So one of the key messages here is fix engine is closed source. It's our biggest source of revenue. Making money from open source is very hard. Most companies out there that make money from open source get most of their revenue from investors, not from clients. So yeah, so there's very few companies that are actually really profitable, and they're usually the really big ones. They have huge scale, and that's how they manage to achieve their sales. So we're profitable, but only because we're very small as a company, so our costs are low enough. So that sort of model doesn't particularly scale very well. We did a solution for a client last year. So one of the key another key message is that we're a very developer-led. So infrastructure is very developer-led. Developers see our products, they like the solutions, and they put it into production. Maybe a year later, a manager realizes they're using our products and it's important, and so they might contact us and eventually pay us some money. So it's very indirect. Part of the problem is that developers generally don't have budgets. So the people who like the product don't have money to spend. They have to convince people who do, and as you'll see in a moment, that's challenging. So our solution at the moment, so this is a solution we put together for a client about a year ago. It's a sort of model solution. I talked about it in the last presentation, so I won't go into too much detail, but I mentioned it in this talk. I also talked about who we are. I still have the most answers for Java, JVM, memory, file I/O, and concurrency. And these ones I'm actually a bit more proud of because that's in any language. So C, C++. I'm the only holders of these 3 badges. And this was our engagement model. And to a large degree, we've scrapped most of this. And then we went on to Q&A. Now, so the purpose of what I showed you wasn't actually to tell you more about the company, but it was actually the feedback, not just from that presentation, but also from all the banks I spoke to. The feedback was, well, we don't really get what you do, right? Which is sort of like, okay, what would you get then? So for me, I thought that was very clear, and I was very pleased with it. And in reality, the only reason why we got into that lab was that I had a lot of hits on the internet. So if you Google me, I get about 100,000 hits. And they were more impressed with that than anything I said in my presentation. So they thought, well, he's very smart, but I don't understand what he does at all, right? And that was the general feedback from all the people on the business side. What we do there is just too nebulous to them. It's solving problems that they've never had to think about and probably not interested in thinking about. So this is a big challenge, right? So you've got developers who love our stuff, but don't have a budget. People who have got budgets don't really understand what we do, and possibly don't want to know what we do, because they want IT to worry about that, because that's their job to worry about. So yeah, it's a bit of a challenge, right? So we went through many presentations. We gave pitches, various iterations of these pitches to 12 different banks. One of them was in Turin, which was really good fun. It was probably one of the best organized because they flew us all out there and had the best food as well. So they were really good. So some banks were a bit more organized than others, but all of them helped in various ways. And in fact, probably the bank that helped us the most were the ones who were the least interested. And that's because they sort of really got through the point to me that they just don't get it. It's just too nebulous for them. So one of the things I realized was that they really want something that does an X or a Y or a Z, and it fills a need that they actually have. How they achieve that, how someone else achieves that, they're not too worried about. So we ended up coming up with a different presentation so we did a pitch at the very start and a pitch at the very end of the program. So this is the pitch at the end of the program, and you'll see it's quite different, apart from the very first slide. which is basically the same. I talked about what I do and use more logos this time, more friendly colors. So we start putting more about what is the business case for using our stuff. And that is that Java developers are in short supply. I've spoken to a number of banks. The banks who have got some money usually have the problem that they've got a shortage of not just 1 or 2 developers, but tens of developers that they cannot find and they cannot hire. They're struggling to hire people for a number of reasons. One is that banks are it's a very dry environment, so there's a lot more fun places to work. But so if you're competing against, say, Google or Facebook or those sorts of companies, they often have trouble competing. On the other hand, in places like London and New York, they often pay better. And certainly in London, in the fintech area, they often pay about 1/3 more than the same job somewhere else. So that's something to take into account. That doesn't mean that they're actually any less friendly to work there. It's just that a lot of the problems you're solving are very dry and very removed from everyday experience, in the sense that, like, if you work with gaming, you've used games, you play with them, you understand them. Whereas a lot of the stuff in fintech and in trading, you're trading millions of dollars, sometimes a second. So for example, I worked at a hedge fund. There were 5 of us in the whole company. On a quiet day, we turned over 2,000 trades a day. The minimum trade size is $1 million, so we were turning over $2 billion a day on a quiet day. On a busy day, we did about $17 billion turnover. But it's all a bit removed from reality, because on every one of those $1 million trades, we were looking to make about $10 to $20 profit. So it's a very small margin, so it's very derived. And on the busiest day, we were making $20 a trade. If you multiply that out, $20 a trade times 17,000 trades, we got, it's about 340,000 profit in a day. It's not bad for a company. Or 5. It's a bit of a different environment, and so there's some challenges there. So you have to find that kind of aspect interesting. So what we really focused on is what is our value add? And our value add is making developers much more effective. And we've had some good successes in that, in taking developers with good business knowledge, but not necessarily the technical skills, and then getting them to be able to deliver a solution in a matter of weeks, when previously that project had failed, for example, at 10 times the cost. So by making developers more effective, now notice one of the emphases is we make developers more effective. We're not looking to fire people, which is another way of interpreting that equation. And that's why, because we're emphasizing that there's a shortage. So you will have less of a shortage if you can make the developers you have more effective. So it's only really the organizations that can't afford to pay for the developers they've got where they would even consider trying to reduce numbers. But that's actually fairly rare in our experience, that they're not interested in spending the money to do this in the first place, because they don't have those kind of budgets. So the main reason we make developers more effective is by giving transparency to applications. Because we use a record everything model, we can record everything going in and out, and even in some cases we've either increased the throughput by a factor of 100, or we've reduced the code base by a factor of 100. And we've had some situations where we've done that in terms of number of lines of code. And at the 50 percentile, we had a guy I consulted with, one of the best developers I've worked with. He developed a greenfield solution before he used our software. After he used our software, he halved the in-application latency. And that's by recording everything, which he didn't do before. So it's perhaps a surprising result. And the reason was that by recording everything, you could see what the application was doing, realized there was quite a bit of things it was doing which it didn't need to be doing. And by cutting all that out, even after recording everything, it was still faster. So some numbers around that in terms of effectiveness and how much we actually get paid. So these are the typical use cases. So these are quite significant for us because we're shifting from this being our typical use cases to actually offering these as solutions. So not necessarily helping other teams develop these solutions, but actually doing it ourselves. So we have a template for these products. They need to be more fully fleshed out, but in particular the marketing side of it needs to be done. But these are systems that we've developed before. And we can develop again. And the reason for shifting this way is these are products that business people understand. This fills a particular requirement. There'll be a box on their architecture diagram that matches one of these or something similar. And in particular, we found this a much easier sell to the business. Because it's a much easier sell to the business, we're talking also more zeros, basically, literally one more zero in terms of the sort of deals that they're looking to offer. So that makes a big difference. So my key advice to you is try selling, if you do have your own business, try selling a product, not necessarily infrastructure, not necessarily consulting. Consulting is a great way to start and fund yourself, but at some point, if you can offer a product, you will end up with a much healthier business. So how do we compare against the market? So they suggested we put together a quadrant, and we were the only team that actually, everyone did a quadrant in the program, but we're the only ones that put scale on it, whereas everyone else had just had arrows and it was all sort of subjective. So we're looking to be both long-term storage, as indeed Hadoop and Spark are, but also very low latency real time. So we can get latencies much lower than other even low latency solutions, and by, in some cases, 3 orders of magnitude lower latencies, which for transactional systems is key because in many cases you can't do the next transaction until you handled the previous one. So you don't know the next one will be successful until you know the previous one was successful. It's like any kind of simple accounting. When you're taking money out of an account, at some point you stop. So you don't know that transaction will work until you know where the previous ones worked. And because of that somewhat serial nature, you need to have low latency. You can't just take money out of account across multiple systems and expect that to scale very well. So we had a project, as I mentioned, there was a project last year. They'd actually hired an external company to do it. They spent 6 months and $1 million using all the latest hardware, C++, and they eventually gave up. And they got us in, and in 8 weeks they were into production, and they spent 1/10 of the money. So I reused the example that I mentioned earlier about the trading system, and this example with just the quote, and same example I mentioned earlier, and that we have four clients, main clients who are actually paying, which is significant because a lot of our stuff is open source. Most banks are using our software for something somewhere, but it's all free. And we're trying to take steps for them to encourage them to contact us so we know who's actually using it, which is part of one of the challenges we're trying to overcome. And so we got a couple of more interest from the partners in the program. So interestingly enough, as I mentioned, that was still way more technical than anyone else in the program, right? So still far too technical for most of these people. And in fact, in hindsight, the only one that really mattered was this slide. And the shift from typical use cases and to offering these as products. And that's the main thing that gets their interest and so on. So hopefully that key point, if you take away one point from this, is that if you're going to do your own company, think about what sort of products that you can offer, because that will help the company a lot more than trying to do consulting or trying to do infrastructure or open source. So open source is great for marketing, by the way. I get a lot of business that just comes to me through things like open source. But that doesn't scale because generally speaking, they want me. and I can only be in so many places at once, and I like to go on holidays occasionally. So whereas with products, if you sell a solution, then you can sell it based on the value that business gets from it. So say, for example, you've got a product that might be saving the company $5 million a year, right? And you sell it for $1 million, then that's a bargain for them. The value to return is only a few months. But that doesn't mean it costs you $1 million to make that product. The amount of cost that you to make that product could be a tenth of that. Usually isn't, but nevertheless, it's just some fraction of it. And so you're not necessarily selling yourself on a per day basis. And so you can scale up a lot better. And that's the kind of shift that we're trying to go towards. Okay, so that's pretty much the end of my talk. Has anyone got any questions?
What's your marketing team size?
Until recently, I was the marketing team, part-time. And the most of the marketing was through my reputation. Things like I have the most answers on Stack Overflow, that helps a bit. I have a blog with 4 million hits, that helps a bit. That's had 4 million views, that helps a bit. The open source is probably our main source of marketing at the moment, and we're looking to continue that. So that's quite helpful because it shows that what we can do technically as well as just being able to talk about these things. So that's been our main source of marketing. So we're looking to shift that. I have a commercial manager now who is looking more about how we pitch to businesses rather than pitching to developers, which has always been our route in the past, is to get a developer who's excited about a solution and then champions it internally. Whereas, we want to put material together we can pitch to the business. And that's where we're looking to go. And we'll probably hire someone, at least part-time initially, to write that for us, because we're not the best people to write marketing material that comes from a business perspective.
What's your the products that you're developing and offering here? Are they simply badged versions of your open source thing? And for example, the fix engine you mentioned was one thing that you said was a closed source. What's the general thing that you've got to?
Yeah, so what we have done in the past is we've attempted to provide commercial extensions to our open source products. That worked to a degree, but it wasn't a particularly good source of revenue. Using that model, we've still found that about 80% of revenue came from consulting, which wasn't really great. Whereas Chronicle Fix, just being partly by virtue of being closed source and partly by being virtue of it's a product the business actually gets. They know they need to have a fix engine, or at least that's something that they already understand. They understand what a fix engine is. We don't have to explain to them the difference between shared memory and all that sort of stuff. So by having a fix engine, that shifted our products and support to being 60% of revenue. So 40% for consulting now. So that was quite an important shift from us. It's still a very low-level infrastructure product from the business perspective, and about as low as they're interested in going. So for the new products, they're actually going to be more up the stack as we see it, building more products that are more focused on implementing business rules. We're not necessarily providing the business rules, but providing a container or framework which will allow them to build those. And in fact, one of the things I didn't mention on that list is a strategy engine, which allows you to dynamically load up strategies on the fly and manage multiple versions of a strategy for the same inputs and be able to switch between them. So they're the sort of approach we're looking to move to. And if we follow that model, we sort of expect then that consulting might actually disappear as an offering in and of itself. We may make it that consulting is now bundled in as a part of delivering the solution, and that'll be more our approach in the future, is to sell one of these solutions to companies And that might come with some training, and that might come with some consulting or workshops, but not necessarily something we offer separately and of its own. Yes?
One of your examples, you halved AWS costs for somebody.
Yep.
How widely applicable is that? Assuming you're using Chronicle Map to code?
Yeah, so the main thing we're looking to do is we provide high performance infrastructure. So there's a couple of different approaches to distribution and data storage frameworks. One approach is to act as an enabler. So it enables you to distribute an application that previously or conceptually is kind of like it's running on one machine. So data grids are a good example of that. You can code against a data grid and you don't have to change the structure of your application too much, but you can sort of enable it to run on many nodes. That works well if most of the work is in your application. And the infrastructure is just glue, an enabler to allow you to use more CPU across more boxes or more memory across more boxes. So most messaging solutions, most data grid solutions I see as being that kind of system. And the priority there is usually making it simple to use as possible, which is one of the advantages of those systems over, say, ours. We've had to put in a lot of work to make it simple to use, but it's still probably not as simple as it could be, in the sense that to get the best performance, you have to restructure your application as event sourcing. But a lot of people are still in the data grid mindset. They want a total synchronized view of everything in a distributed system, and obviously that comes with lots of caveats and performance hit as a result, but they're happy to take that because it's, from their point of view, it's conceptually a lot easier to understand and grasp. Sorry, what was the question?
Well, you kind of answered it. I was asking you about managed to halve the AWS costs.
Yeah, so we have the AWS costs. So if your shift is you just need an enabler, then that's how most solutions work. What we try to do though is we try to have really lightweight infrastructure. So if actually most of your cost is not in your application, but in fact in your infrastructure, in your messaging layer, your persistence layer, by just making that much more efficient, you can significantly improve the performance without having to change much of your code at all, as long as it sort of fits within the models we use, like either it's a key value store or it's an event source.